My name is Eric Shnell. I'm the founder and CEO of Craitor. About 4 years ago, my team and I were first introduced to the digital manufacturing unit out at Camp Pendleton. This unit of Marines was tasked with finding a way that the new and cool technology of 3D printing could be implemented to support their supply chain. The only issue is 3D printing was falling flat. See, while it allowed for us to enable distributed manufacturing, 3D printing sucks at printing in expeditionary environments. Many environments our warfighters find themselves in. And at that point, we decided that we could make a difference there. And so we founded Craitor, a 3D printing platform that prints where no one else can. A rugged, portable, intelligent, mobile 3D printer built in the field alongside our US Marine Corps. And when I say in the field alongside our Marine Corps, I mean that quite literally. Our office is at Camp Pendleton, and we've been working in the field every day alongside our Marines, testing and developing this technology, printing components where and when they're needed. We do this by a CRADA, or Cooperative Research and Development Agreement, a formal partnership between our company, the Marine Corps, and NIWC Pacific, and actually, as of yesterday, the US Army as well. We've had so much success that the Army joined us, and the Air Force is looking to sign a CRADA with us later this year. We've even been identified for potential programs of record to be served next year. Now, what's a program of record? They set the standard within a service, and because 3D printing is so new, these are the first program of record that are coming out within the DoD. They're a large-scale contract. We're talking hundreds of units, winner takes all. And the first one, the Marine Corps TAC Fab, is being decided in 2023. We uniquely qualify for it, and we're working to scale to be able to reach that. A potential up to $12 million contract. Now, what sets us apart is the key features that we've defined with our work alongside the Marine Corps. Man portability, mill standards, printing under transportation. That's right, this has been thrown in the back of an amphibious combat vehicle and printed under operations 100% successfully. High temperature ultrapolymers, of which we are the only printers out there that can do portably, and integrated machine intelligence. The potential here is quite substantial, and it's only growing. $280 million alone in contracts within the next 5 years across our DoD. And it's not just the DoD. That's the beginning. We look to test and legitimize through the DoD, but push and scale through industrial and commercial markets, primarily in expedition industries, oil, gas, mining, disaster relief, construction, and medical. Our team is very experienced both on the commercial side and also within the DoD. Myself and Akil, who are both here, are researchers from UC San Diego, where we started this, and Dan, our COO, is actually our counterpart from the opposite side, who helped start additive manufacturing within the Marine Corps. We're also supported by strong advisors across the board. We're currently raising $3 million to help support our efforts to develop to this program of record and scale. This leads to 10 printers made this summer and the leveling to a scale by next year. And this is just the beginning. With your help, we can potentially put the necessary technology in the hands of our warfighter and beyond. Thank you.
All right, questions from the panel?
What kind of printing materials it supports, and also can you benchmark based on printing speed?
Absolutely. So we can print any FFF or FDM based material. That's filament materials, all the way from the most basic of PLAs, all the way to high temperature ultrapolymers. We're the only portable high temperature 3D printer on the market, and we're able to print medical grade components where and when they're needed. As far as speed, it's highly dependent on the detail of the part. We can make a print that is as big as our entire print space in just over 12 hours with the least amount of detail, or that same part can take days, depending on the amount of detail required. So we're able to scale based off of that, based on the potential need within the field.
What are some of the first use cases you're targeting in terms of, in the field applications? What are you printing?
Yeah, what are we printing? So actually my team back here has a couple parts. If you want to hand it around to the group up here. These are some parts, and I can actually share more afterwards. We brought our museum with us. That is various parts that we've printed alongside our Marine Corps. Parts that have been identified, reverse engineered, and printed in the field, every one of these. So for example, that one right there is a bracket that reinforces broken pack frames that we built and 3D printed overnight up at the Mountain Warfare Training Center in the high Sierras. We printed that in sub-zero temperatures and were able to fix pack frames while they were out in the field running exercises. That one is a ski binding from the same event. And that one right there is actually the part that we printed while we were in the back of the amphibious combat vehicle. As you can see, it printed perfectly despite us putting so much strain and stress on it.
So what is the major product you're selling here? Is it the crating of an existing 3D printer? Or
No, we've developed this 3D printer from the ground up. We started that way. We started with essentially a printer in a box and supporting that. And we realized that it wasn't capable enough. Not only was it not survivable, we couldn't actually print on the move, and we couldn't do high temperature materials. So what we have done is we've built from the ground up a rugged, portable, intelligent system that integrates sensor fusion to be able to survive in these rough environments and be able to ease printing capabilities for the operators.
Great. Two quick questions. First, say hi to Jenny for me. Where are you in terms of the SBIR process and any kinds of grants or contracts you currently have with the military?
So we do not have any direct contacts at the moment. We are actually working on that on the Air Force side and developing some of those. We are primarily funded at the moment through bootstrapping, of which $60,000, and friends and family of about $170,000. We're looking to supplement our current fundraise of $3 million with either contracts through an OTA with DIU, or looking through SBIRs with some particular groups, specifically with AppWorks and some of the other programs there.
And then are you providing the power or is your customer providing the power?
To the unit. So right now, the customer provides the power. It runs off of a standard outlet, and it actually has different modes for different power draw. For example, we can run directly off of an inverter in the back of the vehicle, and we can actually scale the power based off of what power you need. However, we are working on modules that add capability in the future. One of them is actually a battery-powered module because we've been working in the field and one of the operational conditions is limited power. For example, in some cases, they can only run a generator for an hour a day. So these battery systems are meant to essentially supplement the capability here. And this entire system has been designed to be essentially backwards compatible with the modules we're developing in the future. There's multiple of them, including solar panels and some of the other options that we look to do in the future as well.
Are you using an open source operating system or your own?
Yeah, so we use an open source operating system and a modified open source slicer or the software platform. So the reason we do that is because the Marines and actually the other service members are trained on an existing open source platform. So we want to make it as low barrier entry as possible. And also because then, like, for example, a Marine who just wants to play around with it can actually download it freely off of our website and be able to play around with it before they even get it in their hands. If we can minimize that barrier to entry, we get more potential customers in the long run. Now, that also, however, goes together with what is not open source, is our quality assurance package. So we use our sensor fusion suite and the capabilities and the data that we've developed from working in the field and that we will continue to develop with our first units to build out an automated quality assurance report that prints alongside every single part that we print, that validates that the part printed to specs and provides any information for the operator so they don't have to sit there watching it for 8, 12, 10, 24 hours. So they know that that part printed correctly and that overnight their buddy didn't come in and open it up and shake it all around and stuff like that. But if he did, it also gives them a confidence interval of, did that have any effect? Do we think that that was important, whether or not? So they have the most information available to be able to know whether that part is reliable. That is actually part of our IP along with various other components and is part of our current provisional utility patent that we just actually had our PCT published today. I just got a notice of that from our lawyer. So, yeah.
So I'm curious, just thinking about like actually, is this in the field? Is it at a forward operating base? I mean, you know, because like I'm also thinking about like the actual like feedstock for producing the materials in terms of like how much do you actually like. How many parts could you make when, like, is it, like, are those side panels controlling it? Like, I'm just trying to think about like, what is the actual footprint of what we're talking about here relative to what the output is?
Everything within this case is everything you need to be able to print continuously for a week in the field. That includes reverse engineering tools, post-processing tools. All the software and capable equipment is embedded directly into the system. There's a computer front end that goes on a little swing arm out here that isn't on this current version right here. And materials. So the materials, you have enough to print throughout the week, and that can be based off of what materials you might need. And the consideration for the deployment of this system is all you really need to do is supplement it with materials that you need. We're also working, I mentioned the module for battery. Another module we're looking to add is also a material storage module. Those basically snap on top of us, same exact kind of footprint as this one, and provides that not only material storage, but a lot of these materials are hygroscopic. They readily absorb water from the atmosphere, which ruins them. So it also has conditioning for those materials and allows them to be reliable no matter where in the field you are. I was scrolling through here primarily because I was trying to show some of the application environments. So I'm going the wrong way here. But all these photos are all photos of us printing. It's a little slow. That was printing up at 12,000 feet up in the high Sierras. This was, we strapped the back of a Humvee and drove it for 15 miles in the backcountry. These are all parts that were printed in the field. And this was us printing ULTEM in 0 degrees Fahrenheit. ULTEM, high temperature material, actually requires a chamber temperature of around 80 degrees Celsius. This was printing in almost negative 20 degrees Celsius. So we can print in any environment without like air conditioning, supplements, humidity control, any of that.
And is your business model, you sell the full units to your customer, or are you leasing it to them or charging them per project? Like how do you make money?
Initially, we sell the unit upfront. That includes a maintenance contract that comes alongside of it. And that also includes materials of which we certify and approve, working with third parties, and also trainings that come alongside it. We're looking in the future, that quality assurance package that we've developed and have protected is also something that we look to develop alongside our DoD and then begin licensing to other contractors who look to be able to not only potentially 3D print, but do various other manufacturing in the field alongside our warfighters.
How are you planning to maintenance these?
Maintenance these? So the entire system, the core components that typically fail in 3D printing that we've seen from actually doing it in the field are all modularized and replaceable in under 5 minutes. So you can either carry spares on you, or you can send them back to us and we'll directly replace it. Both reduces cost on our end because it makes it easy for us to service without having to send someone out there, and increases uptime on the systems in the field.
But you're never physically going to be present with your unit once you sell it.
Not never, but less often due to the fact that most critical failure points are modular and easily swappable.
All right, one quick question from the live stream. They wanted to know if there's commercial applications outside of the military applications.
Absolutely. And I can hop over here really quick. I know we're a little bit running out of time here, but I do have a perfect slide for that. So we've begun initial market research into expeditionary industries, those we refer to as oil, gas, mining, disaster relief, construction, and also medical. I mentioned high temperature ultrapolymers. Specifically, one of those is ULTEM. That material is actually medically certified, is comparable in strength to aluminum, and is steam autoclavable in the field, so you can sanitize it in the field. We are looking to use that application for medical 3D printing in the field to support field hospitals, disaster relief, and various other capabilities like that.
All right, thank you very much. Oh,
The weight.
One more.
How much does it weigh?
How much does it weigh? It weighs about 173 pounds, so it falls just under 2-man lift mill standard certifications for the DoD.
all right, thank you very much.
Thank you very much.